Well, we've been talking about fractions, and let's just start out with some some. Let's start out with what, like fractional. Well, let's start out talking about a whole. A circle will be our representation of a whole, a pie chart. So that's a whole. And we've been talking about fractional fractional parts of a whole circle. Right? And this would represent a number, a whole. And any number that's represented in a form like this, whereas the number over itself is just going to be equal to 1, no matter what it is. Any number represented like this, and you could go on to infinity, you know, making it the wrong way. It's always going to be one whole. But we've been talking about whenever the denominator, well, the numerator, is always less than the denominator, which is this bottom number, denominator. We've been talking about cases like this. Fractional parts, right? Not whole parts. If I went one more, it would be this. So 3 of these, because this represents a third, right? Well, actually 2 of them, 2/3, right? If I went to 3/3, I already explained here, it's going to be a whole. Well, it would be a fractional part. So we've been talking about stuff like that, like something like this. Right? So represent 3/4. So this is what we've been, no matter how many multiples of them, 18 over 20, 23,000 over 16 million. We always been talking about where n is less than, that is, this numerator is less than the denominator. But what we haven't talked about is the case where we have mix between the whole number and the fractional part. Like, for example, 4/3. 4/3 4/3. 1/3, 2/3, 3/3, 4/3. So we have 1 and 1/3. We have a mixed number. We haven't talked about that. How to go back and forth between a mixed number, which would create an improper fraction like 4/3, because now the numerator is greater than the denominator, or equal to, greater than or equal to. So how do we go back and forth between these two? Convert back and forth between these two. Go from this to this and this to this. Well, to go from this to this, whatever this number is here, we multiply times the number of thirds that we have. In this case, there's 3 of them, so we get 3, and then there's 1 more, so we get 4/3. 1 times 3 plus 1 is 4/3. Let's do that again with maybe a 6th. How about, 8/6. 8/6. So let me see here. You gotta excuse my drawing powers. Trying to do the best I can here. So I will make each one of these a 6. This could have been better. Okay, so if we have 8/6, we would have 1, 2, 3, 4, 5, 6, 7, 8. And now we have 8/6. So we have 1, right? And 2/6. So 1 and 2/6 is equal to 8/6. How do we convert back and forth between these two? Well, going this way, 1 times 6, right? 1 times 6 plus 2. That's 6, 7, 8. 6, 7, 8. 6, 7, 8. 1 times 6, 7, 8. 8/6. Don't change this ever. This always stays the same. This never changes when you're converting here to here. So I've shown how to go from here to here, and from a mixed number that is 1 whole plus a fractional part, 1 whole plus a fractional part, 1 whole plus a fractional part, and represent it as an improper fraction, because this is not really a fractional part, but I can represent it that way. And that's what I'm doing. So how do you go back the other way? From this to this? Well, first you find out how many 6's will go into 8, or how many times can I do an 8/6, regardless of the remainder. Let's go back up here. Well, 4 divided by 3, you only can do that once, and then there's a remainder. So there goes your 1, right? So I'm going to that now. There goes your 1. And then how many would be left over? I only took one of them out, right? 3 over 3. That's what it would represent. Remember what was up here doing this? So 3 divided by 3 would be 1. Let me show you what I mean. So we see we have 1, 3 over 3, and then what's left? Only 1 3 is left. That's how we get 4/3, right? So we have 1 here. So we write it as 1 and 1/3. Same thing happens here. I'm going to convert to this mixed number. Well, 6, right? 6 always got to be there. 6 over 6. Now we have our 1, or however many, plus we need 2 more to make 8. So now we have our 1 and 2, 6. So now you know how to convert back and forth. You know how to get here, and you know how to get here. I'll leave you to think about it for a little bit. Just think about that.